Hi, Kira. Can you hear me? Say yes. Or type yes if you can hear me, please. Hey, got it. Someone type yes so I know you can hear me. All right. Hey, awesome. Sorry about all that. I have no idea what went on. Who knows? I was going in circles trying to fix it. All right. I'll wait till everybody else gets here and then just going to lecture tonight and then do test prep and we're good to go. So we have plenty of time, actually, to do this. Make sure you have paper and pencil and make sure you have a calculator because you're going to need them both tonight. This is weird. What if I do it like this? That's a little better. Let's see if I can get some more light. All right. All right. Over there. I used it that way. All right, just waiting for the other folks. I hope I didn't lose everybody. Hey, Yun Meng, welcome. Welcome. Good, we're on our way. Hey, Karina, can you text Luis and see if he's on his way? Thank you. Thank you. Oh, someone else just arrived. Hello, who just got here? Hi, Chu. Yeah, me too. But I think we got it set up. Did you have trouble with the new link? Hi, Lizeth. Hi, Christopher. How are you feeling? How's your arm? All right. I got Christopher, got Lizeth. Luis, Ruby. Hi, Ruby. Ruby. Let's get Luis. Okay. Okay, I think this is pretty much everybody who was here last time. He was here before. Jackson. Let's see. Let's give it one more minute. Let me see. Luis, did you get here? There you are. Nikai, I gotcha. Hi, Jackson. Sorry for all the kerfluffle. I think we got it figured out. Okay. Well, I say we get started. All right. I want to pick up where Yunmeng left off. She is asking a really good question, and that was on our chart. If you all go to the worksheet here, on this chart, we had three things, right? We had the total number of tones on the scale, we had the interval, and we had the ratio. And Yunming kept asking, where did this come from? Because it was like mysterious. Everything else made sense, but this didn't. But the reality is that this is actually what happens in the real world. And I think actually next year I'm going to teach it, next semester I'm going to teach it starting here rather than starting here. I start with the scales, but I think I'm going to start with the strings. So you should have filled in the ratios. We did those last Wednesday. Is everybody good? Okay. Is that better? Better, Lizeth? For me, it's clear, so I don't know what the deal is. All right, I'm just going to continue. So we had those ratios, and you all should have had that from last time, right? So those should all be filled in. Good. So here's what this means. What this means is that in the physical world, okay, if I take a string, this is where this starts. It starts right here. And if I cut that string in half and I play this, in other words, I play the whole string and then I play the half string, I get the same note. And it's very pretty when you play it together. By the same token, if I split, here's my whole string, and I split that string into three parts, and I cut off this part and I play the whole string, and then I play just 2/3 of the string, then I get a really beautiful sound. All right? And then what Pythagoras found was that the third thing happens too, that if I have a string, okay, and I cut it into 4 parts, and I cut off this part, and then I play the whole string, and then I play 3/4, I get a pretty sound. And I think everybody can see the pattern. 1/2, 2/3, 3/4, that's where the pattern stops. 4/5 doesn't work. Okay? So this is just the way the world works. Hey, Adelina, did we get the blurriness fixed, folks? Did you see that? If you go to the quality under settings, it changes. Does that work? Okay. So we have 1/2, 2/3, 3/4, and Yunmeng, this is just the way the world works. And what happened was then, given that the world works this way, people came afterwards and said, well, then how do we then make music? And then they invented the scale and they did all that other stuff. All the stuff I taught you before came from this. Okay. So right now, before we go to the next part, I'm going to ask, if possible, have a calculator out. You're going to need it. And a piece of paper and a pen or a pencil. Is this the right one? The right what, Felicity? All right, I'm just going to move forward. Now, here's what Pythagoras said. I want to show you one thing. If I take a string, okay, and I cut it in 2/3, I cut it into thirds. Everybody good? Okay. And then I cut off 2/3 right here. Okay. So this would have a ratio of 2:3, meaning I have 2 parts out of 3. 2 parts out of 3. Everybody with me? I'll say it again. This ratio says that I have 2 parts, 1 part and 2 parts, out of a total of 3 parts. 1, 2, 3. 2 out of 3. Okay? Good. Now, what if I take this one right here and I cut into 2/3 again? So I take this whole thing and I'm going to cut it into thirds. Okay? So now I have 1/3, 1/3. And I'm cut it again right here. Okay? So now out of my whole string right there, I now have 2/3. So what I did was I cut by 2/3 and then I cut by 2/3 again. Does everybody understand what I did? It's the same as if I take a piece and I cut a half of a circle, right? And then I cut a half of a circle again, right? I cut by 2/3, I cut by 2/3 again. Good? Okay. Now, my question is, how big is this compared to the whole string? Okay, there's my question. Okay, so what part of the whole string from here to here is that part? All right, so now here's what I have to do. I'm going to take this part right here and I'm going to draw it right there. So my original had 1/3 and 1/3. Good? 1/3, 1/3, 1/3. Now I'm going to cut each of these into 1/3 again. Good? And then I'm going to take 2/3 of those. So I have 1, 2, 3, 4, 5, 6. 2/3 would be 4 of these. 1, 2, 3, 4. There's where I cut it again. So now I want you to notice in this 1/3, I cut it into 3 parts. So that means that's 3 parts, 3 parts, 3 parts. 3 parts is here, 3 parts is there, 3 parts is there. So that's 9 parts. And I took 1, 2, 3, 4 of those. So 2/3 of 2/3 equals 4/9. Okay? Okay? 2/3 of 2/3 equals 4/9. Okay? That's all you need to know is that, Felicity, don't worry about it. I gave a long description. It doesn't matter. Just follow me right here. Is that when we take 2/3 of 2/3, we multiply the numerators and we multiply the denominators. That's it. If we take 1/2 of 1/2, what do we get? We get 1 times 1 is 1, 2 times 2 is 4. 1/2 of 1/2 is 4. Very simply, 1/2 of a $0.50 is 25 cents or 1/4. Okay. Are we all good? Does everybody understand? Give me a yes, an okay, whatever, because now we're going to move forward and we're going to have an activity that should take about 20 minutes and then I'll do test prep. Okay? Is everybody good? The main thing I want you to know is this. When you take a proportion of a proportion, you multiply them. That's all you need to know. You just multiply them. Okay. Good? So Yunmeng, very simply. Okay, you just multiply. That's it. Thanks, you got it. Good. Here we go. Everybody ready? Mr. Pythagoras had a problem. He had a big problem. And here's the problem. And it haunted him, and it haunted Pythagoreans for centuries. And here's the problem. If I take a big old string, okay? All right? And I cut it in 2/3, that's about right there. Okay? And then I cut this part in 2/3 again, which is about right there. Then I cut this part in 2/3. Okay, and I just keep going. All right. I should get to ... Okay, I'm going to do this over and over again. I should get to the same note again. So if I started at C, I should get back to a C somewhere up here if I keep taking 2/3, if I keep taking a fifth. All right? Does everybody get the basic overall concept? I keep going by fifths because remember 2/3 is the interval of a fifth. If you look at your chart, when we cut the string by 2/3, that is the interval of a fifth. So if I walk by fifths, if I keep going up by fifths, okay, I should get back to the same note. Now, normally, I would ask you to do this. And classes rarely have difficulty figuring it out. But in the interest of time and because we're doing online, I'm going to do it for you. Okay? So here we go. Here's our goal. Our goal. I want you to count by the interval of a fifth. Okay, count by the interval of a fifth until you get back to the first note you started with. Okay? Everybody got it? We're just going to keep counting by fifths. We're going to start at C. Okay, let me do it this way. Let's do on a new piece of paper. And I'd like you all to write this with me because I'm going to ask you to do a little math. Okay, we're going to start at C. A fifth is 3 1/2 tones. So we'll start at C. Good? So a fifth above C is 3 1/2 tones. C to D is 1. D to E is 1. 1 plus 1 is 2. E to F is 1/2. That's 2 1/2. F to G is 3 1/2. That's 3 1/2. That's a fifth. And that's 2/3. So the next fifth is a G. Okay? Everybody just give me a heads up that you understand what I'm doing. I went up by a fifth from the note I started with. Is everybody good? Type an okay, let me know. Thank you, everybody, for letting me know. Everybody else, are we good? Excellent, excellent, excellent. Thank you, thank you. All right, now we're going to go 3.5 notes above G. G to A is 1. A to B is 1 more, that's 2. B to C is a half, that's 2 and 1/2. C to D is a 1 more, so that's 3 and 1/2. So a fifth above G is D. Okay, let's do the next one. D to E is 1. E to F is a half, so now we're at 1 and 1/2, 2 and 1/2, 3 and 1/2. So the next one we get to is an A. By the way, this is what I'm doing right here. This would be a G. I cut it by 2/3. When I cut what's left by 2/3, I get to a D. When I cut what's left by, oops, my bad. When I cut what's left by 2/3, I get to an A. This is all I'm doing. I'm getting those same notes by cutting each time I do this, I cut the string by 2/3. Okay? Now let's start at A. A to B is 1. B to C is a half. So that's 1 and 1/2. C to D is 2 and 1/2. D to E is 3 and 1/2. Good? I'm going to keep going. It's going to get tricky now. E to F is 1/2. F to G is 1, so that's 1 and 1/2. G to A is 1, that's 2 and 1/2. Plus 1 more is 3 and 1/2. Okay? Now we're at B. B to C is 1/2. C to D is 1, so that's 1 and 1/2. D to E, here it gets tricky. 2 and 1/2. So we're right here, and we need 3.5. So E to F is 1/2, so that takes us to 3. We add 1/2 more, that's F sharp. That's 3 and 1/2. Real quick again, if you're following me, just give me an okay. I just want to check in before I continue. I'm counting by fifths. I'm counting by 3 and 1/2 notes. I'm counting by 2/3. Are we all good? Thank you, folks. Thank you. Thank you. That helps. Now we're at F sharp. Good, good, good. Now we're at F sharp and we need 3 and 1/2. F sharp to G sharp is 1. G sharp to A sharp is 2. A sharp to B is 2 and 1/2. 3. C sharp is 3 and 1/2. Okay? Now we're right here at C sharp. Oops, my bad. Let's get that down. Okay. We're at C sharp. That's where we are. So C sharp to D sharp is 1. To E is 1/2. So that's 1 and 1/2, 2, 3, and 1/2 G sharp. Okay? So now we are at G sharp. G sharp to A sharp is 1. 1 and 1/2. 2. Okay, we're at C. 3. 3 and 1/2 D sharp. Okay? So we're right here. D sharp to E is a half. E to F is a half. So that's a half plus half is a whole. 2, 3, 3.5, A sharp. Okay. Now, A sharp to B is a half, to C is a half, so that's one whole. To D is one whole more, that's 2. To E is 3. To F is 3.5. Okay? At F, F to G is 1, G to A is 1, A to B is 1, so that's 1, 2, 3.5. And I want you to notice we made it back to C. So we started at C, and we ended with C. All right? And I'm just going to go back to our original drawing. We cut the string by 1/3, by 2/3. We cut it by 2/3. We cut it by 2/3. We kept cutting it by 2/3 until we got somewhere over here, and that was a C. So this big C and that little c are the same. Okay, is everybody with me? You understand what it did? Give me a thumbs up, whatever, so I know you understand before I move on to the next part. Okay, thank you, folks. Now, we're done. Now the question is this. I'm going to bring this paper down. Here's our next question. How many octaves is this? An octave, as you'll remember, is that one note to the next note higher. Okay, so it's that C to the next higher C. How many octaves is this? So we counted by fifths, and if you notice, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is equal to 12 fifths. Yes, Ruby, that's a good question. You continue the process until you finish with the letter where you started. Absolutely good question. So when we count by fifths, it takes 12 fifths to get back to that letter. Now our question is, how many octaves is that? And an octave is back to C. So watch what I'm going to do. It's a little tricky. I'm going to start with this C. If you'll notice, there is no C between C and G. C, D, E, F, G. There's no C in there. But there is a C right here. G, A, B, C. There's a C right there. So there's another C right here. I'm going to count by octaves. Here I counted by fifths. Here I'm counting by octaves. Okay? So D, E, F, G, A. There's no C in here. A, B, C. There's a C right there. Let me do one more. E, F, G, A, B. There's no C, but B, C. There's a C right there. Once again, give me an okay so I know that you're following me here. Everybody else, are we good? Luis, are you still there? Karina, you could start from any letter you wanted. You could start from a B flat. You could start from an F sharp. It doesn't matter. Um, it's exactly the same. And that question, by the way, is a very, very complicated question. Um, I could now monologue for another 2 hours around that question, but let's just say that you can start at any note you wanted because it doesn't matter what note you start with. And the note that we call C is really just the sound that is made by a string of whatever length. That's it. Doesn't matter. All right, so let's continue. There's a C right here. C, D, F, G. Now we have F sharp, G, A, B, C. There's a C before C sharp. Then C, D, E, F, G, no C in here. G, A, B, C, there's a C right there. E, F, G, A, no C in there. A, B, C, there's a C right here. And then we get up to that C. So the question is, how many octaves do we have? We have 1, 2, 3, 4, 5, 6, 7. So if we count by fifths, like this, there are 12 of them. If we count by octaves, there are 7 of them. Cool? So we can say okay, it's going to get weird right now. So is everybody with me here? Everybody with me? It's going to get strange real quick. And this is where you're going to need your calculators. All right. No, you don't. You know what, Sadrina? That's a great question. You don't count the letters. You count the spaces between the letters. All right. Here we go. Remember our rule. Every time. So before we start, I want to point out that this note should be the exact same note. It's the same note. Oops, my bad, I'm off the page. That C that you arrive at should be the exact same note. All right? Everybody with me? Felicity, I'm guessing your connection's a little slow. You can go back afterwards and watch the video if you want. All right, so this C right here should be the exact same note. What that means is the interval of 7 octaves should equal the interval of 12 fifths. So every time you add a ratio, you multiply. Okay? A fifth equals 2/3. An octave equals 1/2. We figured that out. That's on your worksheet. So we're going to do this. We're going to multiply 2/3 times 2/3 times 2/3 12 times. Okay? So we multiply 2/3 times 2/3 times 2/3. Every time we take a fifth interval, we multiply by 2/3. Every time we do an octave, we multiply by 1/2. So give me an okay and let me know that you all are with me. All right, so what I want you to do is take out your calculators, and I want you to do this, and I want you to do this. Those two should, oops, my bad, sorry. Because 7 octaves equals 12 fifths, that should equal that. My question to you is, does it? So go ahead and do the math in your calculators, okay? And remember the button, this button will give you the exponents. If you turn your calculator sideways, you'll get that button, and that'll give you the exponents. When you've got the answers, go ahead and put them in, please. Go ahead and type them in. Christopher, really good question. Um, so some people, I'd say about, it splits to about 50-50. Half of the people look at this interval as 2 to 1, and the other half look at the interval as 1 to 2. So if you go actually read the kind of math of music, kind of how they do the math of it, I don't know what the difference is, but some people do it that way. And in the end, it's the same. It comes out to be exactly the same thing. And I have already updated my packet for next time to make it 1/2 and 2/3. I don't know why. I think I copied that from somewhere. But I prefer to think of it as 1/2 and 2/3. So, but it doesn't matter. You can do it the same either way. I hope that helps. All right, are we good? Type in your answer when you're done. Yun Mei, do not turn it into a decimal. Okay, Yun Mei, go back and don't do it as a decimal. Here, just in the interest of time, I'm going to move forward. So let's do 2/3 to the 12th. Okay, oops, right here. So watch what I'm going to do. I do 2 to the 12th equals, and then I have 3 to the 12th equals, all right? So 2/3 to the 12th will equal 4096 over 5344. Excellent, Yunmeng. This one, 1/2 to the 7th, equals this. So now my question is, are those two equal? Okay. Is this equal to this? So, and here's where it's going to get a little bit hairy. In order to prove whether those two are equal, we have to have common denominators. So in order to make common denominators, we do this. Do you all remember doing this to find common denominators? Okay. Everybody with me? Yun Meng. If I wanted to add 3/4 plus 1/5, those two numbers have to be the same. So I multiply this one times 4/4. I multiply this one times 5/5. And I get 15/20. And right here I get 4/20. Do you notice I multiplied by the same thing over itself? I took this denominator, put it here, this denominator, put it there. That is just what I did right here. Okay? And I get this. So we're done. The point is, I want to show you that this is not equal to this. 7 octaves does not add up to 12/5. Even though we cut the string in such a way that it should work, the math doesn't work. Okay? So what that means, I'm not going to go, the next step would be to figure out the difference right here. The difference is about 1/7 of 100 of a percent. That's the difference. The bottom line is that all music is out of tune. This difference, okay, oops, my bad. This difference right here always has to be made up for. Okay, so back, I told you long ago at the beginning that originally this was split in half. Okay, and there was one that was F sharp over here, and there was one that was G flat over here. And they had 2 different notes. And that's because if you have 2 different notes, the G flat is actually a little bit different from the F sharp. If you do that, then you get rid of that. Okay? So things are just slightly out of tune. All right? That's the point of this whole lesson, is to show you that that the math shows you that things are slightly out of tune. Everybody who makes instruments, when they make their instruments, what they have to do is they have to figure out where to hide that. Every single instrument maker hides this somewhere. The guy who made my instrument, he hid it at the very top on the very end. So that's where he hid it, because no one usually plays those notes. So he hides all of that right there. But if you play those notes, they sound awful. They sound really, really bad. Um, but all instrument makers hide this little bit somewhere. Pianos are tuned so that every string is out of tune. When a piano tuner tunes the piano, they tune every string a tiny bit off in order to account for this 7/100ths of a percent. So the Pythagoreans were very upset about the fact. They started with this idea, okay? This idea of this, that these intervals on the string that were very pretty were perfect numbers. And what they came to at the end is that they are not perfect numbers and that they actually don't work. And this has been an issue in music ever since then. Every generation deals with this in a very different way. So there we are. Does anybody have any questions? Did I put you all to sleep? Did I lose you? Give me a hand here. Let me know you're still alive. No, you're not still alive? So I killed you off? All right. Let me do the test prep. Christopher, none of this will be on the test. This was just about showing you about the music that we listen to actually has all of these mathematical relationships, and that everybody who's played music, not everybody who's played music, but the people who thought about music, wrote about music, anybody who made an instrument, all instrument makers have to think about this stuff. They don't just think about it. Every instrument maker makes their instruments, every instrument maker going back as far as we know, makes their instruments dealing with these problems. They have to, because the math takes you there. And all kinds of composers throughout history studied this stuff and wrote about it and composed. When they wrote their music, they actually thought about these things. Beethoven, Bach, Brahms, they all thought about these things. They all knew about it and they all worried about it. With my instrument, the frets on the lute are movable. And there are lots of composers that tell you to move the frets, and you move it a little bit this way, a little bit that way, to account for this thing called the Pythagorean comma. That zero is called the Pythagorean comma. Okay? And people worried about it forever. Okay, Felicity, wake your mom up because now I'm going to do test prep. Okay? Number one. Okay. So I'm going to give you 4 notes, and you will have to make 4 major scales starting on each of those notes. Is everybody clear what I want? Just G. Okay. You would take your piano, and remember step one, write the letters. Okay, so if we're starting at G, G, A, B, C, D, E, F, G. You write the letters. Number 2, you put in the intervals. 1, 1, 1/2, 1, 1, 1, 1/2. Okay? And number 3, G to A is 1. We leave it as it is. A to B is 1. We leave it as it is. B to C is 1/2. Very good. C to D, 1. D to E, 1. Now, E to F right here has to be a whole, but that's just a half. So we add a half more. Okay? And there's our scale. I want you to notice that you have to write the first letter and you have to write the G again. I don't know why, but in the other class, a bunch of people wrote up to here and they didn't write that last G. So if you start on G, you end on G. If you start on C, you end on C, whatever. Good? Everybody understand? Number 2. I'll give you 4 starting notes and you make 4 minor scales. The minor scale pattern is this: 1, 1/2, 1, 1, 1/2, 1, 1. Okay? Sorry, make sure I'm on the screen here. Okay. All right, and let's make C minor. Step 1, C, D, E, F, G, A, B, C. Step 2, oh, my bad. Okay? C to D is 1, that's good. D to E is a whole. So in order to make it a half, you have to make that E flat. E flat to F is a whole, F to G is a whole. G to A is a whole, so you need to go backwards. So that's A flat. A flat to B is 1 and 1/2, so you have to go backwards. That's B flat. And B flat to C is a whole, so that works. So you just made a scale on C minor. That's a C minor scale. Good? Number 3. Do you remember how to make a chord? Right? A chord is the first, the third, and the fifth.